You know, every single landscape on our planet, from a massive mountain range to just a simple hill on the side of the road, has this incredible hidden history. It's a story written in stone. So what we're going to do here is learn how to read that story, how to understand the Earth's language. Let's get into it.
I mean, look at this. These are the peninsular ranges near San Diego. And it's not just a pretty picture, right? This is a huge, sprawling mystery. You've got mountains, valleys, plains, a coastline, all made of different stuff. How did all of this get here? And why is it arranged just like this?
And that is the key question. So let's treat this like a real geological detective story. Over the next few minutes, we're going to get the tools of the trade. You know, how to spot the clues, make sense of the evidence, and piece together the whole sequence of events that created a landscape just like this one.
Any good detective will tell you the first step is to understand your evidence. And for us, the evidence isn't going to be fingerprints or witness statements. It's literally the ground we're standing on.
Okay, so the most basic pieces of evidence? The rocks themselves. Geologists sort them into three main families. That's igneous, sedimentary, and metamorphic. Now, each one tells a different part of the story, but the really cool part is how they're all connected to each other.
And this is what connects them. It's called the rock cycle. And this isn't some straight line. It's a never-ending process of creation, destruction, and transformation that's been going on for billions of years. It's basically the engine driving the whole story of our planet. All right, let's actually follow a piece of rock on its journey. It could start out as super hot molten magma, which cools and hardens into igneous rock. Then, over a long time, weathering breaks that rock down into little pieces, like sand or gravel. Water and wind then carry those pieces away and drop them in layers. As more layers pile on, those layers get buried, squeezed together, and cemented into sedimentary rock. Now, if that rock gets pushed way deep underground, intense heat and pressure basically cooks it, turning it into a whole new kind of rock, metamorphic rock. And if it gets hot enough, it just melts back into magma, and the whole thing can start over again. And this isn't a weekend trip, you know? This whole journey can take millions, even hundreds of millions of years. We're talking about entire geologic eras here.
Okay, so we've got our evidence, the rocks. But what about the action, the verbs of the story? What are the forces that move all these rocks around, that break them, build them up, and arrange them into the landscapes we see? That's the next big piece of our puzzle. Well, some of these forces are impossible to miss, right? Like this. A volcanic eruption? I mean, that is one of the planet's most powerful construction crews. It's just spewing out lava and ash that creates brand new igneous rock, new land, sometimes in just a matter of hours. But hey, it's not all big, flashy explosions. There are these quieter but totally relentless forces that are always at work. You've got weathering, something as simple as a little bit of ice freezing and cracking a rock or a plant root pushing it apart. Then you have erosion, which is like the planet's transportation system, rivers, glaciers, and wind carrying all those little pieces away. Eventually, that material gets dropped or deposited somewhere else. And behind all of that, you have these immense tectonic forces causing uplift, pushing entire mountain ranges up to the sky. Okay, so we've got the evidence, we know the forces. Now for the really crucial part. How do we read the timeline? How can we possibly know what happened first? Well, lucky for us, geology has a golden rule. It's like the master key for breaking the code. It's called the principle of superposition. Now that sounds fancy, but the idea behind it is actually super simple. When stuff like sand or mud settles, it forms flat layers, one right on top of the other. So unless something has come along and totally messed things up, the stuff on the bottom has to be older than the stuff on the top. It just makes sense, right? This is the absolute bedrock, no pun intended, of what geologists call relative dating. It's all about figuring out the order of events, not necessarily the exact date. So, if there's one thing you take away from this, it's this. The youngest stuff is on top. That's it. So simple, but man, is it powerful. Here's a perfect real-world example. Let's say you see some tan layers of rock, and then right on top, there are red layers. You instantly know, no question about it, the tan stuff is older. Whatever happened to lay down that red stuff had to have happened after the tan stuff was already there. See? The story is starting to write itself. Okay, but here's where our detective story gets really interesting. What if the layers aren't nice and flat? What if you see them tilted sideways, or bent, or even broken? Well, that's a huge clue. It tells us that a whole other chapter of the story happened after they were laid down. Some massive force came in and shook things up. All right, we have the basic tools now. We know about the rocks, the forces, and that golden rule for reading the layers. So, I think it's time to head back to our original crime scene and crack this case.
So let's look at this image again. It's not just a mountain range anymore, is it? Now we have our detective eyes on. We can start to spot the actual clues. We can see the difference between that solid bedrock and those areas covered with loose, crumbly sediment. And now we're ready to figure out what that means.
Think of this as your official geological detective checklist. You can use this anywhere. Next time you're outside, ask yourself these questions. What colors do I see? Are there layers? Are they tilted? What's the texture of the rocks? Are they smooth or all jagged? Are there cracks? Literally every one of these observations is a clue to what happened right there on that spot.
So what's the verdict? What actually happened here in these ranges? We can put together a pretty good story now. We see those big, solid granitic mountains. That's the old, hard bedrock that got shoved up by massive tectonic forces a long, long time ago. But then you see all that loose stuff? That's way younger. That's sediment that was probably laid down by rivers, which carved out features like river terraces long after the mountains were already standing tall. Remember, the youngest part of the story is always right on top.
So there you have it. You now have the basic toolkit to be a landscape detective. Seriously, the next time you're out for a walk or even just stuck in traffic, look around. Look at the road cuts on the highway. Check out the hills, the banks of a creek. Use that checklist we talked about and just see. See if you can start to read the incredible, ancient story that's written right there in front of you.